Today we're talking about something called modeling. And basically what we are doing is that we are working backwards. You are going to be dealing with a vertex and a point, and you're going to write the equation in vertex form. You're going to be dealing with intercepts in a point, so you'll be writing it into intercept form. And then the last one, you'll be dealing with 3 points, and you're going to write it into standard form. Now, each one of these, there's 3 things that we're doing today, and each one of them has their own process. We're basically going to do 2 examples of each type, and if it's any consolation as to what we did in the 3rd hour, we breezed right through it without too much of a hassle. It sounded like it was going to be really weird, but all of a sudden we're like, oh, I get it. So hopefully the proverbial light bulb will go on for you as well. So when we're modeling these things, this is going to be something we're going to start to do a little bit more and more of throughout the course of the year when we get to towards the ends of chapters. When you get to pre-calc next year, you write functions and you write equations out given certain parameters all the time. So the better we get you guys prepared for that, the better Mr. Tames won't be yelling at me for not showing you. So. Vertex form. What we're going to start with is writing a quadratic function in vertex form. And one of the things that we talked about last hour was that if you don't remember what vertex form is, I would suggest when you're doing these problems to write out the formula for vertex form a couple of times. Because on the test next week, Wednesday, I'm going to ask you to write it out in vertex form. I'll ask you to write it in intercept form, which means you have to know the forms. I'm not going to give them to you. So your vertex form is your A times the quantity x minus h squared, quantity squared plus k, where h and k are your vertex, excuse me. Now, remember when you're filling in the blanks here, if it's x minus h and your vertex is at 2, -3, is your h value going to be -2 or is your h value going to be +2? -2. Remember, you just drop the 2 in here. So you have y minus, or equals, excuse me, x minus 2 quantity squared minus 3. What I've done is just substituted in my h and k. Now, it wants you to write the equation in vertex form given that vertex and that ordered pair. That ordered pair is 4, 1. What do the ordered pairs stand for? X and y. So if I know what x and y are, where do you think I put those in here?
So we're given the thing that's
Yes.
on the right.
You'll be given that. Or it might just say, here's your vertex, here's the point, write the equation.
That makes more sense.
So you're going to be given that information. Now, in this case, I know what x and y are. I just substitute in. Y is 1. I don't know what a is. X is 4. In what variable are we solving for now? A. What's 4 minus 2? It's 2 squared. So I get 1 equals 4a minus 3. Add the 3, and what's a? It is 1. Add 3, divide by 4.
How did you get 1 from that?
Add 3. 4 equals 4a. A is 1. 4 divided by 4. Okay. 4 is where? A times, I just put numbers in front of variables, that's all. So you get A is equal to 1. Now if you're going to write it in standard form, what do? Just rewrite it now. You know your A, you know your H and K. You just rewrite it out. You get y equals A, x minus h, quantity squared, plus k. And that's your answer. Do you have to put the 1 there if your A value is 1? No, you don't have to. Basically, if you think about it, when you start with this y equals a, x minus h, quantity squared plus k, you have 1, 2, 3, 4, 5 variables. You're going to be given 4 of them. Solve for a. And then just rewrite. That's all you're doing. Yes, sir.
you up a little bit.
Okay. Yes, ma'am.
Like when you were solving the equation, when you went from the 1 equals a times
This stuff here?
that,
Yeah.
then you went to the next one. What happened to the square?
What's 4 minus 2?
2, 2.
And what's 2 squared? That's what I'm taking care of the order ops real quick and just rewriting. It just so happened that it was 4s and 2s. It was dumb luck. Alright? Really isn't that scary, is it? Same idea. This is more likely what you'd be given. A vertex and a point. Remember, we were writing this in vertex form, which is y equals a times quantity x minus h quantity squared plus k. You know 4 out of the 5 variables. Usually the only mistake you're going to make when you get to this point is you might accidentally put an x in for h or an h in for x. You might accidentally flip-flop them. So just label if you're not quite sure. Your vertex is x, y. Your point, or excuse me, your point is x, y, and your vertex is h, k.
This is the exact same question.
It's not, it just winds up.
Oh.
It's just dumb luck that I happen to choose 2 problems that were the same. You can start with the same idea. You know 4 of them. Go ahead and just start filling in the blanks. 3 is a 4 minus 2 quantity squared plus, minus 1. Once again, what's 4 minus 2? What's 2 squared? Add 1, divide by 4. It's just dumb luck that I had that happen again. Yes, ma'am.
So if you got mixed up, you would mix up the vertex and the point and flip that, would it not work then? Because
So then now you know what your a value is, so you write out the equation. Y equals x minus 2 quantity squared minus 1. If your a value is 1, you don't need to write it. It's implied. Just like if you have the plain old boring coefficient x, what's the value in front of it? A 1. Okay? That's vertex form. Let's do the other one. And let's use the same idea. If I'm going to get intercept forms, when I'm talking about intercept form, that's when you're given your zeros on a graph. And you have a point again. So the P and Q are your zeros. So I have y equals a times the quantity x minus p times quantity x minus q. I start to fill in the blanks again. I'm going to be solving for a because I don't know what that is. I have a coordinate and I have 2 zeros. I fill in the blanks. My coordinate is -1 and 2. Yes, sir.
What do P and Q stand for?
Those are your zeros.
Alright, so P equals -2 and Q equals 3?
Yes.
Okay.
Yeah.
So this one
This one they just say the same. If you're looking at it here, when you start going in x and y, that's the easy one. So you wind up with 2 equals a. We'll have -1 and -1 again. The p value, well, it's minus -2. What's minus -2? And then it's -3. Because remember, what's happening here, your zeros are the zeros of the factored form. Yeah,
So how do you know which one's P and which one's Q?
it doesn't matter. Because think about what that means. When you have your, if you had a term x minus 2, x plus 3, what are your zeros?
Okay.
2 and -3. Did it matter the order when you had those out like that?
Alright.
Multiplication? No, it doesn't matter. It doesn't matter which one you choose for those guys. Now, once again, the biggest mistake you're going to make is when you're doing some simple arithmetic. You'll miss a sign here or there. What's -1 plus 2? 1. What's negative 1 minus 3?
Negative 4.
What's 1 times negative 4? So I get 2 equals negative 4a. What's a? Negative 1/2. Very good. So now I know what my a value is. I just substitute back into the generic form. Y equals negative 1/2 x plus 2 x minus 3. And I'm done. Yeah. Relatively straightforward. It's the standard form that drives everybody nuts because there's a lot of stuff to do. What's that? Oh, go ahead.
There's a lot of stuff to do.
There's a lot more stuff to do than what this is. Because that was the main reason I was having you guys bring your calculators to it. So try this one on your own. It doesn't give you a graph, but it tells you what your x-intercepts are. Your x-intercepts are negative 2 and 2. And your point is negative 4 and 8. If your x-intercepts, or better yet, if your zeros are at negative 2 and 2, where's your axis of symmetry? Very good. Very good. All right, so fill in the blanks. 8 equals a negative 4 minus negative 2. Negative 4 minus 2. So I have negative 2 times negative 6. You guys get 2/3? And then lastly, we go back to rewrite. Y equals 2/3. And you're done.
That's how you read it, that's how you rewrite it.
Yes, sir. Once you figure out what your a value is, you always go back to rewrite it into intercept form. Because each one of these types of problems is going to ask you whether to write it in vertex, intercept, or standard form. And we save standard form for last because it's the biggest pain in the butt. Questions so far?
Oh, you said on the test, it would be like, you'll know which one to do it in.
All right.
Well,
So we know what's going on. Standard form is your ax squared plus bx plus c equals what? When you're given 3 points, you're basically giving yourself 3 sets of x's and y's, correct? What you're going to be able to do here is the following thing 3 times. That's an x and a y. You agree? If I substitute in x and y into standard form, I would get the following. A times negative 1 squared plus b times negative 1 plus c equals 5. All I did was took the standard form and I substituted in for x and y. Is that right? I'd do that again for the next set. A times 0 squared plus b times 0 plus c equals 3. A times 3 squared plus b times 3 plus c equals 9. Now I left you guys a real big giant hint off to the side there saying where we're going with this and why we need to have a calculator. Otherwise you gotta do this by hand. Let's use a 3x3 system of an inverse matrix. So you wind up with the following. When I write this stuff out, what's negative 1 squared? 1. So I get 1a minus 1b plus 1c is 5. You agree? I put a 1 for the c because just to make sure we understand what's going in for our matrix here. I do the same thing with the next equation. I have 0a plus 0b plus 1c is 3. What's 3 squared? 9a plus 3b plus 1c equals 9. What I want to do now is create a coefficient matrix 1, negative 1, 1, 0, 0, 1, 9, 3, 1. And then do you guys remember how we set up to solve with systems? Inverse. And what do I multiply that by? Very good. I multiply that by 5, 3, 9. Now, the way that the pattern works out is that we have listed going across as A, B, and C. So when you get your answer is going to be a row matrix that A equals, B equals, and C equals. So you type that through, what do you get? 1, negative 1, and 3. Has everybody gotten that far yet?
Yes.
Do you remember how you alpha zoom?
Yeah.
3 by 3?
I accidentally pressed the button when I was in the other meeting.
Okay. Now, I'm not done yet. I have just found out what A, B, and C is, and I need to use that for the standard form. So if A is 1, I get A is 1, so I get 1x squared. B is negative 1 minus bx, and C is 3. Oops. So it'd be minus 1. So in short form, it would be x squared minus x plus 3 is y. I think that's your answer. You're solving for your coefficients for A, B, and C by creating a system. Okay?
You can't. So that's the final answer.
That's your final answer. That A, what you're trying to figure out is what A, B, and C is for the generic form, because your standard form is your ax squared plus bx plus c. And if A is 1, B is negative 1, and C is 3, I'm substituting that in to get the form. Alright. That's about as tricky as this stuff gets. And it's the standard form generally is the one that takes the longest. Let me show you. Can I go to another one? Another example?
Yeah.
All right. Here's another one. I want to write out in standard form. Remember, standard form is your a x squared plus bx plus c. All right. Yo,
Mine keeps saying error.
you have a sign wrong. Double check your signs. I bet you have a sign incorrect. Because what's happening if you're coming up with an error, I bet you it's coming up because your determinant is showing out to be 0. Look at your signs in your matrix. Because let me show you guys a little trick here.
There's tricks.
When you take care of your matrix, this column, this first column, was all the coefficients for x squared, right? All right. What's negative 2 squared? What's 1 squared? What's 2 squared? So this column is always the x squared column. This column is always the x column. What's your x value? And this column was always the C. And what is C?
1.
What are your Y columns then? Did you need to do all the work by hand?
No.
Nope.
Wait.
I'm so good.
Remember, when you are doing this, you're substituting in x squared bx, and you're figuring out what the coefficients are. It was 4a minus 2b plus 1c. X squared. Well, what's negative 2 squared? 4. What's 1 squared? 1. What's 2 squared? 4. X is negative 2. 1, 2. 1's in the C column. Y's are negative 1, 11, and 27. Your answer is 137.
Yeah.
371. 37, so it's 3x squared plus 7x plus 1 is y. Done.
1C.
1 is C.
Oh,
371. So whenever you're given just 3 ordered pairs, first column, square them. Second column is the x's. Third column is 1's. Inverse times the y column.
Wait, the first column is x squared.
X squared.
Oh, wow.
Every time. I was kind of messing with you guys, trying to make it sound like this was scary. It really isn't. Yeah.
Scary.
Because we don't know what it is. Because we don't have an x value, so there's c is not times anything, so it's always just 1. If you remember the coefficients, if you write it out, the coefficient of c every time is always 1.
What if we had
That's it.
an x, a y, and a z? What if we had a 3-dimensional graph? We'd have to use that.
Then you were not doing parabolas. Then at that point, well, when we get to polynomial modeling, we'll worry about that then.
That's next chapter.
I think so. It might be. I don't remember. I always get out of sequence in this book because we always go out of order.
So
You'd think I would know which one it is by now.
It's chapter.
So you don't really even have to know the standard form equation.
You really don't. Do those, please. I've given you guys all odd problems on these again. The reason I'm giving you guys the odd problems on this set here again is so that we can check your work. Check your work. We'll go over a couple of these tomorrow. I will start doing some of the word problem review as far as the the motion stuff with the negative 16t squared, the model stuff that they'll give you with the quadratic. We're going over some of those tomorrow as far as, and also some completing the square and factoring stuff. Just get prepared. Test is a week from today. It just kind of stinks the fact that it's a 4-day weekend or so. What's up?
All of those are odds.
These are all odd problems. Yes, sir. I want you guys to do all the odd problems that we can check your work. Okay?